Hello, everyone, and welcome to episode 6 of Clay Loves Logic, where today we're going to be looking at the puzzle Restricted Access by Kennet's Dad. Let's go through the rules. And as a reminder, I'll put the link to this video in the description. So if anyone wants to try the puzzle on their own, or the link to the puzzle, sorry, I'll put the link to the puzzle in the description. So if anyone wants to try the puzzle, they can follow the link and give it a shot. Okay, normal Sudoku rules apply. You have to put the digits 1 to 9 in every box, in every row, and in every column. Digits along the blue negative diagonal may not repeat. That's going to be these. This will be a unique set of the digits 1 to 9. Some of the grids covered in fog. Placing a correct digit will remove the fog surrounding that digit. We've explained that before, but for example, if this was a 2 and you were right and you put a 2 there, all this fog would lift and you'd maybe reveal new things about the puzzle. A cell filled with a blue digit or a blue square contains an even digit. Why don't we just pencil mark those in? Okay, digits and cells joined by an X sum to 10. I don't see any X's yet, but I'm sure there's some under the fog. Not all X clues are given, okay? Digits and cells joined by a V sum to 5, and all V clues are given and visible from the outset of this puzzle. What that means is there will not be anywhere else where two digits sum to 5. These could never sum to 5, neither could these. And we're also given some info about crop key dots. Somewhere in here, there will be black dots. And if you see a black dot, it will imply a 2-to-1 relation of those numbers. 1, 2, 2, 4, 3, 6, 4, 8, etc. And that is the rules. And let's give restricted access a try. I'm going to just quickly highlight all these and put in my 1s, 2s, 3s, 4s. What I think I'm going to do for the start is quickly just color my 1s and 2s, 3s and 4s. I don't want to color this whole puzzle, but I think coloring these ones because of the negative constraint will be the smart thing to do. And then we'll call these, I don't know, green and yellow. This can be green, this can be yellow, which will make this yellow, and it'll make both of these green, and this will be this sort of tan and rust combo. So what we're going to have to do is think about where rust can go in box 1, because we see 2 of them. And rust can't be here. So this is a rust digit. Okay, and I'm sure we can do that same trick because there's sort of symmetry. I bet you we can do the same trick with green in the bottom one. And we can. Yeah, this is a green digit. And it's from 1, 2, 3, and 4. If we think about yellow, maybe, or what should we think about? Should we think about green in this row? Has to be in one of 2 places. And yellow has to be in one of 2 places. Interesting enough, I guess. What I'm going to be curious about is where does tan go on this line? Because we need to put a tan somewhere on this line. And it can't be here because it's seen there. And it can't be here because it's seen by this pair. It can't be on any of these 3 because it's here. It can't be here because of this. So this is a tan digit. And it's from 1, 2, 3, and 4. And I'm going to guess that that same trick works for yellow to put it there. But let's see. Because, again, this can't be a yellow. It's seen by that. None of these can be yellow because they're seen by this. And this can't be yellow. Yeah, this is a yellow digit. Nice. Let's get our coloring tool. Let's color that. 1, 2, 3, 4. That's going to clean up this. That's going to be green. That's going to be yellow. And that's going to do the same thing here, right? Where that's rust and that's tan. And now we have rusts that are not there or there. So this is a rust digit. And then one of these 2 digits is rust. If we look at these digits now, the tan ones, is there anything else to get? Tan has to go somewhere up here. Can't be there. This is a tan digit from 1, 2, and 3, 4. One of these 2 has to be tan digits. 10 in this box. Not there, not there, not there. Can only be here or here, which means it can't be here, because if these are the only places rest can be, it would be a pair. So in fact, this is going to be in that setup. And now we're going to know that all of these are from 1, 2, 3. Oops. Rust, sorry. Are from 1, 2, 3, and 4. Again, now we need a 10 digit. It's going to have to be here in this box because Sudoku, our good old friend. Same thing here, which means this is not 10, which means this is 10. 1, 2, 3, 4. I always make that mistake. So 10, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have all our 10 digits. Excellent. What about yellow? Yellow, yellow, yellow. This has to be a yellow digit. And then we're going to need a yellow digit. Can't be there, can't be there. This is a yellow digit. Yellow digit's going to have to be somewhere down here. And yellow digit is going to have to be somewhere down here. And actually that does it, right? Because this is yellow. This is now no longer yellow. This has to be yellow. This is a 1, 2, 3, 4. That's going to be all the yellows. What about rust? Do we have all the rusts? We have a whole bunch of the rusts. We have 1, 2, 3, 4, 5, 6, 7. So we will have all the rusts. This is rust. And then this is going to be rust. Just by dint of Sudoku. And is that all of them? I think, oh no, we still need to finish green. Green is going to have to be here by Sudoku. Green is going to have to be in one of these two places. Oh, but it can't be there because if it's beside a yellow, it sums to 5. And there's no V telling us that that's okay because it says that all V clues are given invisible from the outset of the puzzle. Then we need a green digit in one of these two. And of course, it can't be there because it can't be by the yellow. So that is going to clear up green. And now this is going to be done. Green is going to be done. And now that is the digits 1 through 4 in every square, which means when we look at these, now these have lost their ability to be low digits. They just have to be 6s and 8s. That's interesting. Okay, so let's think about where a 5 goes on this diagonal. Because it can't be here, given this 5, right? And it can't be here, given this 5. So there is a 5 on this diagonal somewhere in this middle box. Yeah, just has to be. Okay, so 6, 7, 8, 9. So maybe what should we do now? Should we color the 6s and the 8s? Maybe. I don't know what will color them yet, but maybe we should. Yeah, because the colors will be a little ugly, I think. But maybe we color one pink and one pink and one blue. Can we get any better info on these 5s? I wonder. I don't think so. Well, okay. This has to be a pink. This can't be a 5 anymore. Oh, yeah, that's how we do it, right? Because this can't be a pink. Like, look at these pink digits, right? Where does pink go? Pink has to be there. And then the opposite. That's so nice. Because where does blue go? Blue has to go here. This can't be 5. This is blue. Nice. We're going to get a digit. That's a 5. Cleared a little fog. Let's color it. These two digits will be from 7 and 9 now. Oh, okay. I bet you we're going to get a bunch of 5s. I hope. Can we get any more 5s? Thinking. Where does a 5 go here? One of these 3 spots? Is that interesting? One of these 2 spots? One of these 2 spots? One of these 3 spots? And one of these three spots. No, not interesting, unfortunately. Okay, well, let's keep coloring in some of these pinks and blues and see if we can't figure out anything else about it. Because, well, if we have a 6 and an 8 on it already, on this diagonal, these can only be from 7 and 9. So we need a pink digit. That's, no, blue. Blue is what we need. Because look at this. Look at box 1. We need a pink, a blue, and another 7 or 9. This is already one of the 7 9s, which means blue can't be in this row. Blue can't be in this row. This is a blue digit. Yeah, that's nice. And then that means this is a blue digit, which means this is a pink digit. This is a blue digit. And then one of these is pink. I don't know which yet. That's okay. But this is blue. You know, none of these can be blue because of this blue and this blue. So this is blue. It's lost its ability to be 5. It now has to be from 6 and 8, which means a 5 has to be here, which means this is not a 5. And it's going to be a pink. It's kind of just, it's funny how these digits are just kind of like bouncing off each other around the grid. One of these has to be a blue. Okay, what about pink? Where does pink go? Maybe not yet. Let's think. One of these is a blue. And then, oh, that's where, right? If we look at box 9, none of those can be a blue. And then neither can any of these. This is a blue digit. It's a 6, 8. This is not a blue digit anymore. And this is lost its ability to be a 5. It must be from 6 and 8. And that doesn't give us any more digits yet, but let's keep looking at, is that all the blues now? That's all the blues. So let's look at pinks. We have 5 pinks. 1, 2, 3, 4, 5. We need a few more. Where would a pink digit go in this box? This is a 7, 9 already. We know that. So this is a pink digit. That's nice. That's a 6, 8, which means this is a pink by Sudoku, 6, 8, which means this is a pink by Sudoku, 6, 8, and this is a pink. Can't be a 5, has to be a 6, 8. That's going to be all our 6, 8s. And now this has to be a 7, 9. And this has to be a 7, 9. And we're really trucking through this puzzle now. I'd like to get these 5s. I feel like we should be able to figure out, but maybe not. Maybe not yet. This is from 7, 9. These are 5, 7, 9. These are 5, 7, and 9s. These are 5, 7, and 9. I'm just going to pencil mark everything. If I could. Of course, this isn't a 5. These are going to be from 5, 7s, and 9s. These are from 5, 7, 9. And then these are from 5, 7, 7, 9. And of course, this isn't a 5. I really don't want to color these in. Let me just stare at this for a second and see if there's a way to not have to color in our 7s and 9s. Okay, we'll just color them in. I'm not going to color in brown because I need a better color, right? I could use blue, but look how hard that is to read. Let's use brown for this 7 and 9. And what haven't we used? Purple? Okay, brown and purple for our 7s and 9s. That's going to be brown. That's going to be purple. So that's going to be brown. So one of these is brown. Oh, this is purple. We know that. So this is brown. So can this be a purple? It can. So can this. So these would be from purple and 5. These would be from purple and 5. Brown digit. Well, one of these is from purple and 5, and then brown could be any one of these. Same thing here. This is going to be brown and 5. This is going to be brown and 5. This is going to be brown, purple, or 5. This is going to be purple. This is not purple anymore. This is brown and 5, which means this is not purple. This is purple. It's not a 5. This is going to do it. Ah, nice. Okay. There's lots going on now. That's immediately interesting. This can't be a 5 anymore, and it is in fact purple. This is a 5. That's going to clear up some stuff. That's going to make this a 5, which is going to make this a 5, which is going to make this a 5, which can make that a 5. And we have all our 5s. And we can clean up the coloring. Right, we can remove all of those browns and our pencil marks. These can't be 5s anymore. Oops, it's the wrong color. Okay, 7s and 9s. Well, okay, look at this, right? Oh, no, this is more interesting. This is more interesting. Look at this. A 7 and a 9 means we can get rid of 2 and 4. It has to sum to 10. So, okay. Yellow can only be from 1 and 3. And if you look at this, we have a 6, 8 that became clear. And a 7, 9, a 10 pair. So 1 and 9 sums to 10. That's fine, but 1 can't double to 6 or 8. It can only double to 2. So this can be 3, and all of our yellows are going to be 3, and that's going to do a whole bunch immediately. All the yellows are 3, which means all the blues are 6s. Which means this digit and this digit and all of our other browns. I don't have all the brown math figured out yet, or the math, but the coloring. I think it has to be this one and this one, right? All these are going to be 7s. So then, okay, where do we go from here? Green is 2. So this can't be a 2 or a 3. It can only be a 1 or a 4, and it has to pair with this. So pink is 8. 10 is 4. Rust is 1. This is a 9. This is a 9. This is a 9. This is a 7. Oops. 9. Oh, and we're not done. I got ahead of myself here. The coloring made it hard to see. 9. Oh, 7 because of the color. Great. And that was a good puzzle. 18 minutes, quick one. 925 people have solved it in 118 days. I do like this puzzle. Okay, let us, in proper spirits, let's just go ahead and finish the coloring. Yeah, I know, I've solved it. Oh, I don't want to make custom colors. I'm just going to color them in. 9s. 9s, we're going to color purple. And let's give 5s the last color, which is going to be, what is the last color? What haven't we used? Dark blue. And we'll color in our last one. I love that. That was a great puzzle. That was a really, really fun puzzle. I really like the deduction using this diagonal in combination with, the coloring of the pairs to be able to place them on the diagonals and then realize that these blue boxes that you can't see anymore because they're hidden had to be high digits. And that really got things going, because then you could place 1, 2, 3, 4, 6, and 8 just with coloring. Wow. Kennet's dad, restricted access. Great puzzle. Thanks for joining me, everyone, and I will see you in the next one.